Good morning to one and all. See this, in this today's live lecture we shall continue the part that is the central differences. Now in this unit number 2nd we have studied Newton's forward interpolation formula, backward interpolation formula, Newton's unequal interval, Lagrange's formula for unequal interval. Now we are going to study the central differences. Actually in the last lecture we have seen the definition of the central difference operator delta that is the central difference operator delta. The central difference operator delta, actually here is delta, which is denoted by delta f of x and is defined as delta f of x is equals to f of x plus h by 2 minus f of x minus h by 2. This is the central difference operator, or it is also denoted by using the notation. यालाच आपण असं सुद्धा लिहू शकतो. That is a delta yx equals to y of x plus h by 2 minus y of x minus h by 2. y च्या फॉर्म मध्ये असं पण लिहिता येतं, कारण बऱ्याच ठिकाणी बऱ्याच नोटेशन मध्ये असं पण लिहिलेलं आहे. डेल्टा f of x in place of f of x we can write yx, delta yx equals to y suffix x, y suffix x is equals to y of x plus h by 2 minus y suffix h x minus h by 2. okay, अशा पद्धतीने पण लिहिता येतं. So also we have, see this is the forward difference operator delta f of x is equals to f of central difference operator delta f of x, which is equals to f of x plus h by 2 minus f of x minus h by 2. This can be written as e raised to, actually e means the shift operator, we can relate e and delta. So e raised to 1 by 2 f of x is equals to f of x plus h by 2. Also we have proved yesterday this relation delta is equals to, small delta is equals to capital delta e raised to minus 1 by 2, or which is equals to del e raised to 1 by 2. We have proved this. Also we can write from this delta e raised to 1 by 2 is equals to del याच्यावरनं, आणि दुसरा म्हणजे याच्यावरनं डेल्टा इज इक्वल्स टू डेल ई रेस टू 1 by 2 याच्यावरनं असं लिहिता येतं. परंतु मुलांना काही काल विद्यार्थी विचारत होते, बट वी हॅव टू राईट धिस प्रूफ ऑफ धिस टू, 4 आणि 5चं प्रूफ घेऊ. हे तर अगोदरच्या चॅप्टरमध्ये पाहिलेलंच आहेत. नाउ वी शॅल डिस्कस द प्रूफ ऑफ 4 and 5. वी हॅव टू प्रूव्ह धिस ऑपरेटर इक्वेशन 4 and operator equation 5. Operator equation we have proved yesterday, and equation first and second, note number first and note number second are the definitions. We have proved yesterday operator equation 3. Today we shall prove the operator equation 4 and 5. okay, now we shall move towards this. Prove that delta e raised to 1 by 2 is equals to capital delta. Delta e raised to 1 by 2 is equals to capital delta. So we have delta f of x is equals to f of x plus h by 2 minus f of x minus h by 2, and e raised to 1 by 2 f of x is equals to f of x plus h by 2. Now this is the first definition. We know that central difference, this is the shift operator, both equation 1 and 2. Now we can write, we have to prove this result. So left side delta e raised to 1 by 2 f of x. Now operate this delta in a bracket e raised to 1 by 2 f of x, but e raised to 1 by 2 f of x means from equation 2nd we can write f of x plus h by 2. f of x plus h by 2. Now you can use the central difference delta, means f of x plus h by 2 plus h by 2 minus f of x plus h minus h by 2. ओके, म्हणजे ही डेफिनेशन वापरली फ्रॉम 1 and 2. सो f of x plus h by 2 plus h by 2 means h minus f of h by 2 minus h by 2 means f of x. So delta e raised to 1 by 2 f of x, which is equals to delta f of x. F of x will be get cancel, or comparing the operators, then we get delta e raised to 1 by 2 is equals to capital delta, and hence proved. Now we shall prove second relation. Delta e raised to small delta e raised to 1 by 2 is equals to del. Now we know that according to the definition, delta f of x is equals to f of x plus h minus f of x minus h by 2. So this is 1. E raised to minus 1 by 2 f of x is equals to f of x minus h by 2. Suppose this is equation second. Now we have to prove delta e raised to 1 by 2 is equals to del. So delta e raised to 1 by 2 f of x, this can be written as delta in a bracket e raised to 1 minus 1 by 2 f of x. Now e raised to minus 1 by 2 f of x can be written as f of x minus h by 2. Now operate this delta. Delta means f of x minus h by 2 plus h by 2 according to this definitions here. Delta f of x means f of x plus h by 2 minus f of x minus h by 2. Suppose this is f of x, याला f of x घेतलं तर x minus h by 2 plus h by 2, x minus h by 2 minus h by 2. So it will be minus h by 2 plus h by 2, it will be cancelled. So it is f of x minus h by 2 minus h by 2 means minus h. So f of x minus f of x minus h, this is the definition of del f of x. This is the definition of del f of x. So delta e raised to minus 1 by 2 f of x, which is equals to del f of x. So by comparing the operator e delta raised to minus 1 by 2, which is equals to del, and hence proved. Means here in this case we have proved operator 4 and 5. अशा पद्धतीने आपण 4 आणि 5 ऑपरेटर प्रूव्ह केलेले आहेत. आता याच्यावरनं आणखी एक करता येतं. See here, now we have, what is the relations here, student? We have small delta can be expressed in terms of capital delta and capital del, such that we have small delta e is equals to capital delta e raised to minus 1 by 2, which can be written as del e raised to 1 by 2. So we can write this operator in terms of y. So we can write this operator can be operate on y suffix x. So we can write delta y suffix x is equals to delta e raised to minus 1 by 2 y suffix x, which is equals to del e raised to 1 by 2 y suffix x. Okay, यालाच असं लिहिता येतं. सो डेल्टा y suffix x is equals to delta. Now operate this shift operator, that can be written as y suffix x minus h by 2, which is equals to del e raised to 1 by 2 ला शिफ्ट ऑपरेटर आहे, शिफ्ट करा y x plus h by 2. Now we can write the nth power of taking nth power of these operators so we get delta n y suffix x which is equals to capital delta y suffix x minus h by 2, which can be written as del raised to n y suffix x plus h by 2. We can write in this way also. This is the nth difference operator. This can be represented for nth difference operator. Means delta n y suffix x is equals to delta n y suffix x minus h by 2 del raised to n y suffix x plus h by 2. Okay. So next we shall move the next operator mu, the operator mu, the average operator, the average operator, averager or averager म्हणतात, averager किंवा average operator, or it is called as a mean operator. The average operator, or it is called as a mean operator, and which is denoted by mu. Now we shall define the second operator, that is average operator or mean operator. Students, now you tell me how to find out the mean of two elements. Suppose A is one number, B is another number. Then you tell me, मी सांगतो पाहतो कोण कोण आन्सर देतात. How to find out the mean of two operators? Actually, we have proved this. We have to discuss the difference operator delta, del, mu, e, sigma. We have to define the different operators here. Actually, we have to define, already you know that delta, already you know that difference operator del. Next we shall discuss sigma. Next we shall discuss mu. So already we have seen, one minute, already we have seen delta, capital delta, del, e. Now we have to discuss a sigma operator, next operator, that is a sigma operator. And what is meant by the sigma operators here, we shall discuss here. One minute. The sigma means small sigma. Small sigma means it is the mean operator. And we have to calculate, we have to define the mean operator, average operator, which is denoted by E. And this average operator we can take by using the shift operator. Okay. हा बरोबर आहे, बऱ्याच जणांनी सांगितलेलं आहे. Now see this, we shall discuss this average operator, shift operator. हा तिघांचं किती जणांचं आन्सर आलं रे? 1 मिनिट. Okay. Now we shall define the next mean operator or the average operator. See this, the operator mu called the averager. averager or mean operator and is defined as mu is equals to mean of e raised to 1 by 2 plus e raised to minus 1 by 2. Actually, the average operator, mean operator, is the average of forward shift operator and backward shift operator. That is half shift operator. So we can write this is the shift operator. Average म्हणजे सरासरी. So we can write therefore mu of yx equals to 1 by 2 e raised to 1 by 2 plus e raised to minus 1 by 2 y suffix x. That means 1 by 2 e raised to 1 by 2 yx plus e raised to minus 1 by 2 yx. That means we have to separate this. So we can write 1 by 2 y suffix x plus 1 by 2 plus y suffix x minus, h by 2 minus h by 2. So mu of yx means half of yx plus h by 2 plus y suffix x minus h by 2. This is the mu of yx. See this. This is the operator on yx. Okay. So we can write mu of yx means half of y x plus h by 2 plus x minus h by 2. आता इथं h जर 1 असेल, या ठिकाणी जर h 1 by for h is equals to 1. See this, for h is equals to 1, then we can write mu of yx equals to, we can write 1 by 2 into y of x plus 1 by 2 minus y of x minus 1 by 2. Okay. Now we can operate, now we can take the nth order difference. We can take nth order difference. So also taking nth power of the operator, nth power of the operator, that is mu of delta n yx, which can be written as 1 by 2. आता yx ची व्हॅल्यू आहे, mu of yx ची व्हॅल्यू आहे, so it can be written as a delta raised to n y of x plus 1 by 2 minus, sorry minus नाही आहे, h म्हणजे plus. Very good, we have to take the plus sign because it is the minus. By mistake we have taken minus, plus y of x minus 1 by 2. Now if we operate this, then we get 1 by 2 delta raised to n y suffix x plus 1 by 2 plus delta raised to n x minus 1 by 2. Okay, in this way we can write mu delta raised to n yx. Okay, so these are the different conditions. Suppose this is equation number 1, this is equation number 2, this is equation number 3, and this is equation number 4. Okay, in this way we can obtain. Now we have to prove some relation. Prove that, आता एक रिलेशन प्रूव्ह करायचे. 1 minute स्टुडंट, आपले पेजेस संपलेले आहेत, 1 minute थांबा. Now we shall discuss the next part. Suppose these are the concept regarding average operator or mean operator mu. Mean operator mu can be defined as mu is equals to 1 by 2 e raised to h by 2 e raised to 1 by 2 minus e raised to minus 1 by 2. So we can write mu on yx equals to 1 by 2 yx plus h by 2 plus yx minus h by 2. If we consider h is equals to 1, then mu of yx is equals to 1 by 2 y of x plus 1 by 2 plus y of x minus 1 by 2. Now we can taking the nth power of operator delta n. Here delta n. So mu delta n yx is equals to delta raised to n yx plus 1 by 2 yx minus 1 by 2. So this gives a result. Okay, no problem. Now we have to prove one relation. आता एक relation prove करायचे, महत्वाचं relation prove करायचे. So we shall write here, prove that prove that mu square is equals to 1 plus 1 by 4 delta square. We have to prove this result. Mu square is equals to 1 plus, कुठं राहिलं y? Okay, y. So delta we can write, हा बरोबर आहे, y राहिलं इथं y. Yes, okay, y राहिलं, y suffix. Yes, okay, no problem. Now prove that, कितवा प्रूफ आहे पा? ओके, चौथा. Prove that mu square is equals to 1 plus 1 by 4 delta square. Now according to the definition, we have the average operator mu, that is mu of yx. You know that mu of yx equals to 1 by 2 e raised to 1 by 2 minus e raised to minus 1 by 2 yx. Okay, mu of yx, mu means e raised to 1 by 2 plus average आहे ना, mu of yx which is equals to e raised to, or simple तुम्हाला अगोदर सहज लिहून दाखवतो, सिंपल लिहितो म्हणजे लक्षात येतं. Therefore we have average operator mu is equals to 1 by 2 e raised to 1 by 2 plus e raised to minus 1 by 2. But we have to take mu of yx. Generally f of x च्या जागी इथं yx वापरत चला. 1 by 2 we can write e raised to 1 by 2 plus e raised to minus 1 by 2 of yx. Okay, this is the operator. Now we have to take here delta yx. Suppose this is equation number 1. Also delta of yx means, you know that delta of yx means we can write, what we can write? Delta f of x means f of x plus h minus f of x minus h. So we can write delta yx equals to y of x plus h by 2 minus y of x minus h by 2. So this is our delta yx. There is no problem. Equation second. Now we have डेल्टा स्क्वेअर आपल्याला काय प्रूव्ह करायचे पहा, म्यू स्क्वेअर. तर इक्वेशन 1चा स्क्वेअरिंग करा. सो फ्रॉम इक्वेशन 1 वी कॅन राईट बाय स्क्वेअरिंग of operator mu from 1. So we can write mu square yx which is equals to, आता राईट साईडला सुद्धा स्क्वेअरिंग होतो, 1/4 e raised to 1/2 plus e raised to minus 1/2 bracket square of yx. समजलं का रे? बिकॉज वी हॅव टू प्रूव्ह म्यू स्क्वेअर. हिअर इन दिस केस म्यू ऑफ वाय एक्स इज दिस. नाव स्क्वेअरिंग इक्वेशन 1. ऑपरेटर 1चा स्क्वेअरिंग करा. हा वाय एक्स मीन्स फंक्शन आहे, त्याचा स्क्वेअर होत नसतो, फक्त ऑपरेटरचे स्क्वेअर होतात. सो म्यू स्क्वेअर ऑफ वाय एक्स मीन्स सी दिस, म्यू इज इक्वल्स टू 1/2 e raised to 1/2 plus e raised to minus 1/2. So mu square is equals to 1/4 e raised to 1/2 plus e raised to minus 1/2 its square. So we can take this. Now we can solve. So therefore mu square yx which is given by 1/4. आता याचा एक्सपान्शन घ्या, a square minus 2ab plus b square. So we can write a square minus plus है का minus है plus 2ab 2 times of e raised to 1/2 e raised to minus 1/2 plus b square means e raised to minus 1 of yx. Okay, so we can write this as 1/4 e. आता याला आपण असं सुद्धा लिहू शकतो, e raised to, ओके, यालाच असं सुद्धा लिहिता येईल, e raised to, हां, so this can be written as a 4. So ओके, e raised to 1/2 आपण असं करू वाटलं तर e plus 2 plus e raised to minus 1 into yx. So 1/4 याला डेल मध्ये बदलायचे, लक्षात ठेवा डेल मध्ये. सो e minus 2 plus e inverse, this can be written as a plus 4 yx. काय केलं लक्षात आलं का रे तुम्हाला? plus 2 minus 2 केला, plus 4 minus 2 plus 4 minus 2 means it is plus 2. So we have to added and subtracted minus 2. That can be written as 1/4 e minus 2 e raised to 1/2 e raised to minus 1/2 plus e raised to minus 1 plus 4 y suffix x. This can be written as, यालाच असं लिहिता येतं, which will be 1/4 e raised to 1/2 minus e raised to minus 1/2 bracket square plus 4 of yx. हाँ, very good श्रद्धा, right. बघ आता e raised to 1/2 minus e raised to 1/2 पहा, e raised to 1/2 minus e raised to 1/2 हे कशाचं नोटेशन आहे पहा, लक्षात घ्या. e raised to 1/2 minus e raised to 1/2 याला e चं नोटेशन आहे. याला आपण काय लिहू शकतो? डेल्टा लिहू शकतो, डेल्टा. तुमच्याकडे आहे पहा, ते दिलेलं आहे पहा. सो e raised to 1 by 2 minus e raised to minus 1 by 2, which can be written as 1 by 4 delta square plus 4 of yx. वाटलं तर सिन्स म्हणून लिहा, त्याच्या पुढं सिन्स ब्रॅकेटमध्ये e raised to 1 by 2 minus e raised to minus 1 by 2, which is equals to delta. This is a since. Small delta. So we can write this as, समजतं का स्टुडंट पहा, e raised to minus 4 plus e raised to 1 by 2 minus e raised to minus 1 by 2. So it can be written as a small delta. So replace this value. So we will get, therefore, mu square yx, which is equals to 1 by 4 into delta square 4 of yx. Now multiply by delta. So multiply by 1 by 4. So mu square yx, which is equals to delta square by 4 plus 1 into mu x. So by comparing we can write mu square is equals to delta square by 4 plus 1. That means mu square is equals to 1 plus 1 by 4 delta square, and hence proved. अशा पद्धतीने हे प्रूफ कंप्लीट होतं पहा. प्रूव्ह दॅट म्यू स्क्वेअर इज इक्वल्स टू 1 प्लस 1 बाय 4 डेल्टा स्क्वेअर. डेल्टा म्हणजेच काय होतं पहा, ही सी दिस डेल्टा ऑफ वाय एक्स इज इक्वल्स टू वाय ऑफ एक्स प्लस एच बाय 2 वाय ऑफ एक्स मायनस एच बाय 2. म्हणजे यालाच इथं वाटलं तर लिहा तुम्हाला समजण्यासाठी, विच इज इक्वल्स टू ई रेज टू 1 बाय 2 minus e raised to minus 1 by 2 of yx. याला इक्वेशन द्या सेकंड. सेम आहे पहा, डेल्टा ऑफ yx means y of x plus h minus y of x minus h by 2. That can be written as e raised to h by 2 minus e raised to minus e raised to 1 by 2 minus e raised to minus 1 by 2 yx. ओके, अशा पद्धतीनं हा थेरम इथं या पद्धतीनं लिहू शकतो. सो दिस इज द कंप्लीट प्रूफ. काय अडचण आहे का विचारारे स्टुडंट्स? इफ यू हॅव एनी डाऊट देन यू कॅन आस्क मी. ओके, सो वी कॅन राईट धिस. हां, म्यू एक्स झालं का? ओके, यू कॅन राईट धिस इज अ वाय एक्स. सो बाय कंपेरिंग operators it will be the result. okay, so hence proved. हे खूप महत्वाचं आहे, पहिला IMP करा. so this is a very important. इथे एक ऍड करा, डेल्टा वाय एक्स मीन्स वाय ऑफ एक्स प्लस एच मायनस वाय ऑफ एक्स मायनस एच बाय 2. वाय ऑफ एक्स प्लस एच बाय 2 मायनस वाय ऑफ एक्स मायनस एच बाय 2 विच इज इक्वल्स टू ई रेज टू 1 बाय 2. y of x plus h by 2 means e raised to 1 by 2 minus y of x minus h by 2 means e raised to minus h by 2 which is equals to yx. ओके, सिंपल आहे थेर, काही अवघड नाही आहे. इट इज व्हेरी सिंपल. नाउ वी शॅल मूव टुवर्ड्स द नेक्स्ट. प्रूव्ह दॅट, अगेन वी हॅव टू प्रूव्ह वन रिलेशन. सेकंड, प्रूव्ह दॅट fifth, e raised to 1 by 2 which is equals to mu plus 1 by 2 delta. e raised to 1 by 2 is equals to mu plus e raised to delta. So we shall write this. We have e raised to 1 by 2 yx means y of x plus h by 2. Suppose this is 1. Now mu of yx means 1 by 2. Mu means the average operator, and average operator e raised to 1 by 2 plus e raised to minus 1 by 2 of yx. And also we can define delta. Also delta of yx means y of x plus h by 2 minus y of x minus h by 2, or which is denoted by e raised to 1 by 2 minus e raised to minus 1 by 2 of yx. Suppose this is equation 2, this is equation 3. Actually we have to prove the relation between e raised to 1 by 2, mu and delta. So define e raised to 1 by 2 on yx, define mu on yx, define delta on yx. So now we can take 2 times of, आता काय पाहिजे पहा लेफ्ट साइडला, 2 mu yx plus delta. Now we can take the addition. Here 1 by 2 है ना delta yx. So this can be written as 1 by 2. Mu of yx means 1 by 2 e raised to this. Okay. Now mu plus 1 by 2 delta. Now mu plus 1 by 2 delta of yx, which is equals to mu of yx plus 1 by 2 delta of yx. So we have considered the right side. Now mu of yx means काय येतो mu of yx ला पहा, mu of yx means e raised to 1 by 2. So 1 by 2 e raised to 1 by 2 plus e raised to minus 1 by 2 of yx plus 1 by 2 delta yx means, see this, delta yx means y of x plus h by 2 minus y of x minus h by 2. कुठं मायनस राहिलं रे बाबा? Is it okay? E raised to minus 1 by 2. Yes, e raised to minus 1 by 2. Okay. चला ठीक आहे. यालाच असं लिहिता येतं 1 by 2 कॉमन घ्या. This is mu of yx. mu ची परत डेफिनेशन पहा 1 by 2. आणि 1 by 2 कॉमन घ्या. So we can write e raised to 1 by 2 yx plus e raised to minus 1 by 2 yx. इक्वेशन 2 मध्ये मायनस राहिलंय का? हा ओके. Is it okay, right? So we can write plus y of x plus h by 2 minus y of x minus h by 2. Now operate this 1 by 2 y of x plus h by 2 plus operate this e raised to minus 1 by 2 yx means y of x minus h by 2 plus this I it is y of x plus h by 2 minus y of x minus h by 2. Now see this term and this term, positive negative will be get cancel. So 1 by 2, which are the remaining terms? Y of x plus h by 2 plus y of x plus h by 2 means 2 times of y of x plus h by 2. Again this 2 will be get cancelled, then remaining term is, what is the remaining term? Mu plus 1 by 2 delta of yx, which is equals to y of x plus h by 2. 2 cancel, y of x plus h by 2. But y of x plus h by 2 ला इक्वेशन 1 वरनं e raised to 1 by 2 yx लिहिता येतं. So we can write e raised to 1 by 2 yx. This implies that mu plus 1 by 2 delta of yx, which is equals to e raised to 1 by 2 yx, by comparing operators, we can write mu plus 1 by 2 delta, which is equals to e raised to 1 by 2. So we can write e raised to 1 by 2 is equals to mu plus 1 by 2 delta, and hence proved. हे समजलं का रे स्टुडंट्स? याच्यात काही अडचण आहे का? पा फक्त काही नाही, म्यू प्लस 1 बाय 2 डेल्टा वाय एक्स ची ऑपरेट करा. म्यू ऑफ वाय एक्स प्लस 1 बाय 2 डेल्टा वाय एक्स. म्यू ऑफ वाय एक्स मीन्स 1 बाय 2 ई रेज टू 1 बाय 2 प्लस ई रेज टू माइनस 1 बाय 2 वाय एक्स प्लस 1 बाय 2 डेल्टा मीन्स delta yx means y of x plus h by 2 minus y of x minus h by 2. So operate this. परत याला ऑपरेट करा. 1 by 2 कॉमन काढा. e raised to 1 by 2 yx plus e raised to minus 1 by 2 yx plus this I as it is. परत याला ऑपरेट करा. So we can operate e raised to 1 by 2 yx is equals to y x plus h by 2. e raised to yh means y x minus h by 2. This same. Then this negative positive will be cancelled. Y of x plus h by 2, y of x plus h by 2 means 2 times of y of x plus h by 2. 2 times will be get cancelled. So we get the relation mu plus 1 by 2 delta yx is equals to y of x plus h by 2. This can be written as e raised to 1 by 2 yx. Now comparing the operators, mu plus 1 by 2 delta is equals to e raised to 1 by 2. That means e raised to 1 by 2 is equals to mu plus 1 by 2 delta. आणि अशा पद्धतीनं हेन्स प्रूव्ड. ओके, मग आता यानंतर आता ॲडिशन मध्ये करून टाका. यामध्ये यालाच असं लिहिता येतं, ई म्हणजे सुद्धा लक्षात घ्या, तुम्हाला माहित आहे. ऑल्सो वी हॅव, नाउ वी हॅव कॅपिटल ई म्हणजेच ई रेज टू यू, where u means what? We can write hd. Therefore we already proved e is equals to e raised to hd. E raised to hd. So we can write again the relation delta E is equals to e raised to 1 by 2 minus e raised to minus 1 by 2, which is equals to 2 times of sin h u by 2. या हायपरबोलिक फंक्शन मध्ये डिफाइन केला आणि म्यू इज इक्वल्स टू 1 by 2 e raised to 1 by 2 plus e raised to minus 1 by 2, which is equals to cos of h u by 2. हे 2 कॅन्सल होतं. हे दोन रिलेशन आहेत, नवीन रिलेशन आहेत, तुम्हाला लक्षात राहावं म्हणून सांगितलेलं आहे. हे हायपरबोलिक एक्सप्रेशन आहे. हे हायपरबोलिक एक्सप्रेशन आहे. पहा फर्स्ट इयरला झालाय, तुम्हाला फॉर्म्युला आठवत आहे का? पहा ई रेस टू एक्स प्लस ई रेस टू मायनस एक्स डिवाइड बाय 2 असेल. ई रेस टू एक्स ॲक्च्युअली हायपरबोलिक फंक्शन cos of hx equals to e raised to x plus e raised to minus x divide by 2. हा हायपरबोलिक फंक्शन आहे. sin of hx is equals to e raised to x minus e raised to minus x divided by 2. So we can write in the hyperbolic function form sin u by 2. इथं जर h1 घेतला, h ची जर व्हॅल्यू 1 घेतली, एच डी म्हणजे u घ्या. सो वी कॅन राईट धिस फॉर्म्युले. म्हणून हे फॉर्म्युले आपण लिहू शकतो अकॉर्डिंग टू द हायपरबोलिक फॉर्म्युला. हे फक्त समजण्यासाठी आहे. हा वी कॅन राईट इन द हायपरबोलिक फॉर्म. मग आता हे सर्व फॉर्म्युले आपण कलेक्ट करूत आणि एकत्र लिहूत, ॲडिशन करूत फॉर्म्युलेचे नोटमध्ये. सो ठीक आहे. आता हे 7th नंबर 8 नंबर हा जो नोट आहे तो आपण फॉर्म्युले ॲड करू. सो वी शॅल राईट धिस नोट नंबर 7. What we have proved today in the note number 7, we have proved mu is equals to average operator mu is equals to 1 by 2 e raised to 1 by 2 plus e raised to minus 1 by 2. So note number 8, we have already proved mu of yx equals to 1 by 2 y of x plus h by 2 plus y of x minus h by 2. 9 नंबरचा फॉर्म्युला आणखी एक प्रूव्ह केलेला आहे आपण. पहा mu square is equals to, what is that formula which we have proved? 1 plus delta square by 4. 10 नंबरचा फॉर्म्युला आत्ता प्रूव्ह केलेला कोणता आहे तो? e raised to 1 by 2 is equals to mu plus delta by 2. और वी कॅन राईट 1 by 2 डेल्टा. काही लिहा तुम्हाला इझी जाण्यासाठी. 1 by 2 डेल्टा. इथं पण त्याचप्रमाणे लिहा मग 1 by 4 डेल्टा स्क्वेअर. 11 नंबर. नाउ वी कॅन राईट दिस डेल्टा अँड म्यू इन टर्म्स ऑफ अ हायपरबोलिक फंक्शन, दॅट इज अ डेल्टा इज इक्वल्स टू e raised to 1 by 2 minus e raised to minus 1 by 2. So we can write this as a 2 into sin h u by 2. Here in this case u म्हणजेच hd. u म्हणजे काय? hd असतो. वाटलं तर इथं लिहा e is equals to e raised to u जर पुट केला म्हणजेच e raised to hd. जर h1 घेतला तरी चालतो. सो नो प्रॉब्लेम, ऑलरेडी वी हॅव सीन दिस. सो सेकंड 12 mu is equals to 1 by 2 e raised to 1 by 2 plus e raised to minus 1 by 2, which is equals to cos of h u by 2. Okay, these formulae which we have proved. आतापर्यंत हे फॉर्म्युले प्रूव्ह केले. ते फक्त हायपरबोलिक एक्सप्रेशन आहे, हायपरबोलिक रिप्रेझेंटेशन आहे. बाय युजिंग दिस फॉर्म्युला cos hx is equals to e raised to x plus e raised to minus x divided by 2, sin hx इज इक्वल्स टू ई रेज टू एक्स मायनस ई रेज टू मायनस एक्स डिवाइड बाय 2. अशा पद्धतीनं याला एच बाय 2ला ई रेज टू एचला आपण ई रेज टू एच डी लिहिला आणि एच डी म्हणजे यू घेतला, मग एच डी बाय 2 यू बाय 2 यू बाय 2 अशा पद्धतीनं हे फॉर्म्युले होतात. ओके, ठीक आहे. काय झालं, डेल्टा स्क्वेअर हे प्रूव्ह केलेला फॉर्म्युला आहे ना, ई रेज टू 1/2 इज इक्वल्स टू म्यू प्लस 1/2 डेल्टा, हे आहे ना लास्ट. ई रेज टू 1/2 इज इक्वल्स टू म्यू प्लस 1/2 डेल्टा. कुलकर्णी काय म्हणते, रेणुका कुलकर्णी? स्क्रीन दिसत नाही का? सागर धुमाळ, तुझ्या इंटरनेटची स्पीड कमी झाली असेल रे. स्क्रीन दिसते, स्क्रीनला काही अडचण नाही आहे. इंटरनेटची स्पीड, जर एखाद्या विद्यार्थ्याची इंटरनेटची स्पीड कमी झाली तर स्क्रीन दिसत नाही. ओके, सो आतापर्यंत आपण एवढे फॉर्म्युले प्रूव्ह केलेले आहेत. सो अप टिल वी हॅव स्टडीड, वी हॅव प्रूव्ड 12 different formulae regarding forward difference operator, backward difference operator, shift operator, central difference operator, average operator. प्रत्येक ऑपरेटर लक्षात ठेवा. डेल्टा, कॅपिटल डेल्टा मीन्स फॉरवर्ड डिफरन्स ऑपरेटर, कॅपिटल डेल मीन्स बॅकवर्ड डिफरन्स ऑपरेटर, कॅपिटल ई मीन्स शिफ्ट ऑपरेटर, स्मॉल डेल्टा मीन्स सेंट्रल डिफरन्स ऑपरेटर, स्मॉल म्यू मीन्स विच इज द ॲव्हरेज ऑपरेटर. असे एवढे ऑपरेटर आतापर्यंत पाहिलेले आहेत आणि त्याच्या आधारावर या चॅप्टरमध्ये आपण 12 रिलेशन्स प्रूव्ह केलेले आहेत. ओके, नाऊ वी शॅल स्टॉप हिअर. वी शॅल डिस्कस ऑन मंडे नेक्स्ट पार्ट. काय अडचण आहे का? इफ यू हॅव एनी